Hello, my geometry students. Mr. Knight here. This is 3.3. We're looking at parallel lines. So let's go ahead and get started. We have some theorems to get through and postulate. So we already know that a proof can be written in paragraph form called a paragraph proof, but typically we're just going to stick with a two-column proof. One column for the statement, one column for the reason. So if I look at postulate 16 here, it's corresponding angles converse. If two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. All right. So what they're saying there is I have two lines, line 1, line 2, cut by a transversal, line 3, and it says if the corresponding angles are congruent, then it's saying that these two lines, line 1 and line 2, are parallel. Then if we look at theorem 4, alternate interior angles converse, it's going to be the exact same thing. If two lines are cut by a transversal, like line 1, line 2, so the alternate interior angles, which would be these angles, let me use a different color, these alternate interior angles, if they are congruent, that means that the line 1 and line 2 are parallel. Then if we look at my next theorem, theorem 5, alternate exterior angles converse, if two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. So all they're saying is that my alternate exterior angles, if they end up being congruent, that just means that line 1 and line 2 are parallel. And then theorem 6 down here, consecutive interior angles converse, if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So all they're saying, I'll use black for this. This is my consecutive. So if, and we'll call that 1 and 2, so if angle 1, measure of angle 1 plus the measure of angle 2 is equal to 180 degrees, that means they're supplementary. If they are supplementary, then that means those two lines are parallel. And then my last theorem down here, transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So in that case, you might have something like this. If two lines, here's line 1 and line 2, if they are parallel, if line 1 and line 2 are if they're parallel to the same line, so if line 1 is parallel to line 3, and line 2 is, get that pin out of the way, so if line 1 is parallel to line 3, and line 2 is parallel to line 3, therefore line 1 and 2 have to be parallel to each other. So that's kind of what that theorem 7 states, that transitive property of parallel lines. So let's move on. So apply the corresponding angles converse. So we're finding the value of x that makes j parallel to k. So we have line j and we have line k. All right, so lines, all right, so we're looking at, these would be corresponding angles, right? And if I need for those two lines, j and k, to be parallel, that means those corresponding angles must be congruent. So you set them equal to each other. 7x plus 4 is equal to 53. You find out that x is 7. So when x is equal to 7, I know that lines j and k are parallel. If x is any other value, lines j and k are not parallel. All right. So this is your turn. Oop, one too many. Actually, I can raise that. I can do that. So you have exercises here, example 1 and 2. Number 1 is find the value of x that makes L and M parallel. Number 2, is there enough information in the diagram to conclude that G and H are parallel? So pause the video, run through these two real quick, start the video back up, and we'll check our answers, okay? All right, so if we look at number 1 here, I know that these are corresponding angles, so I know 110 is equal to 6x plus 2, and that gives me 108 is equal to 6x, and x, therefore x is equal to 18. 48, yeah, 108. So when x is equal to 18, I know that lines L and M will be parallel because my corresponding angles will be congruent. And then if I look at number 2 here, is there enough information? Yes, there is. If I look at, I know that this is 70 because these are supplementary angles, right? And then I know that 70 and 70 is equal to each other. And I know that those are corresponding angles, and based on the theorem that we just looked at back in our definitions, when corresponding angles are congruent, then the two lines will be parallel. All right, so that takes care of 1 and 2. Let's see what's next. All right, show lines are parallel. So using the diagram at the right, which is way over here, we're looking at A right now. All right, find the values of x that makes A and B parallel. All right, these are consecutive, right? Consecutives have to be 180 degrees. So if you look down here, they've already done that. they said 5x minus 2 plus the 62 is equal to 180. And you go ahead and solve for x, and x is 24. Therefore, you know that when x is 24, that these two angles these two lines, A and B, will be parallel when my consecutive interior angles are congruent. And then if I look at B, it says find the value of y that makes A and C parallel. So let's see if move this down a little bit so you can see. Yeah, so I can stop it right there because I can say that last statement. All right, so find that makes A and C. Well, if I look at this angle and if I look at that angle, and I'm only looking at A and C cut by a transversal, those are alternate interior angles. Alternate interior angles are congruent. Therefore, 62 is equal to 7y plus 6. And if you notice all the way down here, that's exactly what they've done. So you solve for y is equal to 8. So I know that when y is 8, I know that lines A and C will be parallel. Now, if you notice, go back here real quick. If you look at this theorem 7, transitive property of parallel lines, that theorem 17, I can apply this, although they're not going to talk about it, at least I don't think they are. I'm going to apply that right here. I know that A is parallel to B. I know that C is parallel to B. And I know that A, based on that theorem, that A and B are actually parallel, okay? So let's move on, see if there's another slide. There is another slide. Find the value of x that makes P parallel to Q. So what I want you to do is pause the video, run through 3, 4, and 5, and then once you've done that, start the video back up and we'll check our answers, okay? All right, so if I look at number 3, I know that these are alternate exterior angles. I know that they are congruent, therefore I have 140 degrees is equal to 13x plus 3, and you solve and you find out that x is 11. So when x is 11, P and Q will be parallel. If I look at number 4, I know these are alternate interior angles. I also know that they are congruent, therefore I can set them equal to each other. You have 72 is equal to 9x. You solve for x is equal to 8. So therefore when x is 8, there you go, lines P and Q will be parallel. If I look at number 5, x is equal to 12, I know that these are consecutive angles. Okay, consecutive angles equal 180 degrees. So I know that I have 98 plus 7x minus 2 is equal to 180. Solve for x is 12. So when x is 12, I know that this angle here equal 180 degrees, and when that happens I know that these two will be parallel. P and Q will be parallel lines. Okay, so I think that is it. Let's see. Yep, that is it. So have an awesome day, and we'll see you next video.